Good morning, good morning, good morning. Happy Saturday to everybody. Hopefully everyone's enjoying their weekend, which would have been pre-Oshkosh. Unfortunately, here we are at home, but we're looking forward to the Chris's presentation today and Kristen Winter later on. I know that we've got quite a few things to do in advance here. And first, what I'd like to do is thank everybody for the virtual gathering at WPACA. And I'm sure some of you have been to our gathering in the past, and some of you have not. Every year we have been hosting this gathering at WPACA. It is this weekend, right before Oshkosh starts. And we have our supporters, our advertisers present their services with us at the gathering at WPACA. And here's a little picture of some of our, let's see here, we got right about, this is last year's photo. You can see the amount of people that these people show up, they hang out at the hotel, and whatever supporters are doing a conversation, they'll talk about their product, their service for about an hour, and then we do Q&As, we have sit-down dinners, sit-down lunches. We have the welcome reception on a Saturday. Sunday is all of our gathering, our actual gathering at WPACA, and then of course Monday, beginning of AirVenture. But here we are, obviously because of COVID, we're all stuck at home, and we're lucky to have Chris today doing some presentations, and Kristen Winter later on with the logbooks. But first off, we want to say thank you to Aircraft Spruce for sponsoring these. They're a great relationship with them. And so please, at this point, I'd like to introduce Chris, the Eastern U.S. Sales Manager for Concord Battery, and he's going to talk about lead acid battery and airworthiness. So to this point, the floor is over to Chris.
Thank you, Kent. Welcome, everybody. Appreciate you taking the time out on a Saturday to join us. We certainly all wish we were up in that perfect weather this time of year up in Wisconsin, but we've got to do what we've got to do at this point. So thank you so much for attending, and I'm going to go ahead and share my screen, and we'll get this rolling. So like Kent said, today we are going to be talking about lead acid aircraft battery airworthiness and what that means for you. This is the agenda. We'll give you a quick history on Concord. We'll talk about safety, which is always important for any product. Some people wonder what's safety and batteries have to do with one another. And then temp versus power, some battery basics, some charging methods. Airworthiness is what we focus on a lot because when you talk about airworthiness and batteries, sometimes there's a gray area in what that means and what it doesn't. And then care and maintenance and some regulations and installation eligibility, and then we'll be done. I do have a lot of ground to cover, so I'm going to keep an eye on my watch and make sure that we don't run over time. So here's some of our history and what we've done over the last 43 years. Started in '77. It's founded by the Godber family, still a family-owned business to this day. First mil specs were obtained fairly quickly. We brought the sealed recombinant gas battery to the aviation industry back in the early 80s when flooded was the type of battery that you use for just about anything. Our first general aviation application was the King Air. On the military side, it was the F-18, and we currently fly on about 70% of the U.S. military inventory right now, and we're pretty proud of that. The F-117 really put us on the map. We were the OE battery on that aircraft from start to finish, and it's hard to believe, but that aircraft has been parked in the boneyard since 2009. And then consistent, active industry engagement. Concord's always been known for that. This is some of the things that we do. We sponsor the Reno Air Races. We're the official battery there. We are also heavily involved, as you can see down there at the bottom, if you've ever been to Sun and Fun and obviously Oshkosh. We've been a presence there for going on a little over 30 years now at both locations. Some of the top teams in our business that most of you know, the Aeroshell aerobatic team, Kirby Chambliss, Kyle Franklin. We're also heavily involved with Warbird warbird family, I guess, for lack of a better term. Both of the B-29s, we've supported them, and they're flying our batteries. So we're really proud of what we do in the industry and the time that we take to get involved with all of the programs. And then industry engagement also means giving back. And one of the things that we've done the past 3 or 4 years is we've started an IA renewal series. For those of you who don't know what an IA is, that's an authorized inspector in every shop, and he's the guy that signs the logbook and says this maintenance action was true and correct. So those guys need 8 hours of concurrent training every year. So we have a couple in Florida, one in South Carolina and one in Tennessee, also one up in the Northeast. One of the things that we do is we give a $1,000 scholarship to a local A&P mechanic, a local A&P student that's there at that school. And so you can see a picture of some of the students that we have given the scholarships to over the last few years. And then the picture down at the right, that's the gathering at Midlands Tech down here in South Carolina, where I'm located. So let's get right to it. We'll talk a little bit about safety. If you're still dealing with flooded batteries, obviously you need to be very careful with acid. You need to make sure that you're not getting that on your skin or your clothes. The weight of the batteries is certainly an issue. You've got to make sure that when you're handling these batteries in a plastic container, that your hands don't have a nice sheen of sweat on them. Make sure maybe you've got a pair of engine gloves or something like that that you're using to move batteries around. If you are still using batteries that have acid, where you have to put the acid in the battery, make sure that you're using a funnel, Dixie cups, things like that. We don't like to see nothing worse than filling up a funnel and then all of a sudden the funnel is half full and you've got nowhere to go with that acid. So just make sure you're being careful with that. There's really not a good reason to put a flooded battery in an airplane anymore, and that's certainly something that we're going to be talking about as we go through the program. Now, one thing that differentiates us from a lot of the battery manufacturers is our terminal style batteries are made out of copper. It's a bronze silicon alloy. And the reason that we do that is because the ring terminals on your batteries or on your aircraft are copper. If you put unlike metals together, it's not a matter of if, but when you will see corrosion at that terminal. And you don't think about that as a safety of flight issue too often, but there's a situation here that we've got highlighted on the screen back in '97. There was a Seneca in the air, smoke in the cockpit. They landed and decaled the aircraft. What they discovered is that one of the terminal bolts on the battery had corroded so badly that it broke, and it began to smolder and burn. So luckily, this was a situation where everybody got away safely and the aircraft was saved. But if you're not using Concorde batteries, you're going to see corrosion, and it's something you're going to have to keep up with from time to time to make sure that you don't have any of it around the terminal area. Torque value is fairly important. It's not something you think very often about, but the torque value maximum for our batteries is 70 inch-pounds on the bolt. You don't really want to get much higher than that. You get up above 100, 105 pounds, and you can actually crack the epoxy seal, which you can see in that picture on the bottom left. You can see that crack in the epoxy. That's an easy one to spot. More often than not, the crack will occur right across the plastic dam on the edge there, and you won't see the crack. If you get up above 200 pounds, you can actually crack the brass. So make sure that you're using a torque wrench when you tighten down the bolts on your battery. I will say this, that if that epoxy seal is broken, eventually corrosion will make its way out onto the surface of the terminal bolt. So if you ever do see corrosion on a Concorde battery, just know that at some point in time, somebody has wrenched on that battery a little too hard in its previous history. So here's a common question we like to ask everybody. You know, my grandfather taught my dad, and my dad taught me, son, don't ever put your battery on the concrete floor in the garage because the concrete will suck the energy right out of it, and put it on a 2x4. And really, that's not true. It doesn't really matter where you store a lead acid battery. The issue is temperature. The cooler environment, especially with these sealed batteries, they come charged and ready to use. So the cooler environment that you can keep a battery in, the slower that battery will discharge. In point of fact, you can actually take a fully charged battery, stick it in a refrigerator, and come back a year later, and that battery will have lost maybe 0.3 of a volt. If you sit it out on the ramp here in South Carolina where I live, and it's 96 degrees today, you can bleed a quarter to a third of that energy out in a month or even less, depending on how hot it is. So temperature is everything when you store a battery, not really where you store it, but just the temperature. So let's get into a little bit of battery basics so you understand what the differences are. I've got flooded, gel, and sealed batteries listed here. Gel batteries actually have been out of aviation for over 15 years, but it is a common refrain that I hear at Oshkosh or at Sun and Fun or some of the other places we go to. Folks refer to these as gel cell batteries. Gel was indeed the first non-spillable battery, but what happens is voids develop in the gel. And there's only two things you need a battery for in an aircraft. One is to start your engine. The other is to provide you with essential power to get back on the ground should you lose your alternator or your generator. So if you have voids in the gel, think of a piece of Swiss cheese, any part of that void that's up against the plate area will not charge. And so you cannot reach minimum capacity for an airworthy condition. So gel came and went fairly quickly in the aviation business. So that leaves us with flooded and sealed. The picture on the left is a picture of two cells. The cell on the right is a flooded cell, and the cell on the left is a sealed cell. With the flooded cell on the right, the brown line represents the plate, and you have to have some space between the plates to allow that electrolyte to move around in there. You also can't run the plate all the way to the bottom of the box because over time, the free electrolyte will slosh around and wash the lead oxide off the plate, and it settles down at the bottom of the box. Think of it as a mud. In fact, that sits on what's called a mud rest. And if that mud were to build up high enough over time, it can actually short that cell out. So the cell on the left is a sealed cell, and the plates are bigger. We can put more of them in there because we don't have to have that space anymore. We put all of the acid in what's called an absorptive glass mat, an AGM mat, which is a common moniker for these type of batteries these days. So we soak that AGM mat, we sandwich the plates in there so we can get more of them in there, and then we don't need to worry about the mud rest anymore, so we can run the plates all the way to the bottom of the box. That gives you about 20% more power in a sealed battery versus a flooded battery. And then most of our batteries, all the 24-volt batteries, have what's called a Platinum Series logo, and you can sort of see that on the cutaway on the right there on that 380E. That simply means we've added a few more plates per cell to give you another 18% more power. So you're talking nearly 40% more power in a sealed Platinum Series battery from Concord versus a stock flooded battery that we stopped making about 7 years ago, or my friends over at Gill still make. Now, they're known by a lot of different names, RG, AGMs, the Europeans call them slab, sealed lead acid batteries. RG is the acronym for how the battery actually works. These are recombinant gas batteries. They do have vents, but they're internal. And they're designed so that when the batteries burp, they actually recombine the gas back into the mats, and so you don't have to refurbish them with fluid. Now, we talked about temp versus power a few minutes ago. Here is a slide that sort of shows that to you very clearly. This is an RG380E. It's one of our turbine batteries. And you can see that IPP and IPR ratings are comparable to cold cranking amps. A lot of you have heard that term. In aviation, we call it IPP and IPR ratings. The IPP rating is measured when you turn the key, hit the switch right at around 0.3 of a second. And then IPR is measured 15 seconds down the line with a continuous ask from the battery. So you can see at room temperature in the first column, the IPP is 1,350 amps, the IPR a little bit lower after 15 seconds down to 1,000. But take a look at that second column, 0 degrees Fahrenheit. Look how much the power band falls off. And the real point of this slide is to let you know that if you're operating in colder conditions, your battery is not going to give you its rated power if it is the same temperature as the ambient temperature. So if you're operating in a cold climate and you know you're going to be there, heater blankets, actually taking the battery out of the aircraft, putting it in the FBO overnight, or possibly taking it back to your hotel, anything to keep that block of lead warm when you're working in cold conditions is most appropriate. And then at minus 22, you see the fall off a little bit more, but not quite as much as you might expect. In fact, we've spent a lot of decades up in International Falls working on these batteries, getting them to perform optimally as best we can at cold temperatures. And in point of fact, at minus 20 and below, we're working better than NICADs now. So lead acid has come a long way over the decades, and Concorde has sort of led that charge. This is just a quick show here that Ken Borak went down about 5 years ago to the South Pole to take care of some doctors and bring them back. If you guys remember that mission, we were on board that Twin Otter. It was cold soaked to minus 60 that night. No hangar available down at the South Pole. The next morning, they were able to get it fired up and bring those folks back. So they sent us that picture, and we were proud to make a flyer out of that. But we are really the preeminent cold weather battery at this point in the industry. So here's what we're going to go through in the next little bit. How do you put a battery into service? That's called commissioning. Charging batteries, cap testing. Does it really matter? Is your battery airworthy? How does that relate? Some scheduled inspections, and then we'll be done. So what does it take to put a battery into service? Well, if you've got a flooded battery, you got to take it out of the box, fill it full of acid, let it settle for a little while, put some more acid into it, and then you have to do what's called a forming charge. The first charge on a flooded battery is a low amp rate, 14 to 16 hour charge. And then that battery has to be capacity tested, because no flooded battery has been tested for airworthiness out of the factory. So you have to make sure you've got minimum airworthiness in that battery, minimum capacity. And then you have to charge that battery back up. So if that's done correctly, it's about a 16 to 18 hour process. And you can imagine, if you're transient, being told that you have to wait that long for a battery. Now, I will tell you, and this happens a lot, you can charge that battery up for 3.5 hours, and you will have enough energy in that battery to get your aircraft started. But if you do that, you will have cut that battery's life by about 60%. It's that dramatic. So you need to make sure, if you're commissioning a flooded battery, that you do spend that entire 14 to 16 hour process to charge that battery properly. A sealed battery from Concorde, you simply take it out of the box, check the open circuit voltage, make sure you've got minimum voltage, which is 12.5 volts for a 12 volt battery, and 25 volts for a 24 volt battery. And then you simply put it in the airplane. Our batteries are not high rate tested once, but they are actually tested twice in our factory before they leave. It's not a lot test. We don't pull one or two off of a pallet. We actually test all of our batteries. It's done twice. They're ready to go out of the box. So it makes it much easier and much quicker to put one of our sealed batteries into play. Three basic charging methods: constant voltage, which is also known as constant potential. This is the type of charging you do with every battery in your life, whether it be your cell phone, your computer, your iPads, or the battery in your aircraft. Another method is constant current. Now, this is a method of charging that we use that's similar to a forming charge type of charging method, but it's designed to desulfate a battery to bring it back to an airworthy status. And we'll talk a little bit about that in just a little bit. And then you've got float chargers, maintainers, whatever you'd like to call those. We only have really one that we recommend. I don't make it, I don't sell it, so I've got no skin in the game. But our venerable leader, Skip Koss, who passed away about 1.5 years ago, 11 years ago, I guess it is now, went to Battery Minder, VDC Electronics, and said, make me a maintainer specific for aircraft batteries that does not have to be removed until the person goes flying again, which is a great feature. And those battery minders are wonderful tools. If you don't get to fly a lot, a battery minder is great, because it simply keeps the battery in a like new condition, and it's ready to go when you're going flying. Now, if you fly once a week and you go at least an hour when you go, then you really don't need a battery minder. But if you don't get to fly as much as you'd like, that is certainly an investment that's well worth it. The numbers that we hear from folks who use battery minders religiously that don't get to fly a whole lot, it really extends the life. So look into that if you don't get to fly as much as you'd like. Okay, so first question on the table regarding airworthiness: is an aircraft airworthy with a dead or a discharged battery? And the truth of it is, it's not. Only if it was certified with one, and I don't know many aircraft that were certified with dead batteries. So here's a situation where a battery can paint you into a corner. If you've got an aircraft with a dead battery and you start your aircraft with external power, how long does it take to recharge that battery with the aircraft charging system? And the answer, the secret's in the watch. It's about 3.5 hours. But the situation is this: you're on the ramp, you've got passengers, you need to go, and your battery is absolutely dead. So you call the line kit over, and he gives you a jump, and you're fired up, and you're up in the air and up to altitude in 20, 25 minutes, and your alternator or your generator lets go. The problem there is that if there was not enough energy in the battery to close the relay once the aircraft got going, then no energy went into that battery during that climb up the mountain, and you have no essential power to provide you with the energy you need to run instrumentation, talk on the radio, all the critical stuff that you need to get back on the ground. So really, the important point here, if you don't hear anything today, hear this: please do not jumpstart your aircraft battery. It is simply not worth it. You can get yourself into a position that you can't get out of, especially if you're up there in the soup. This is also an excellent point here, really kind of a highlight of the whole presentation. You see this battery here, it's hooked up to a voltmeter, and it says that the voltage in that battery is 25.83. That is really close to a fully charged 24-volt battery. 2590, 2591 is absolutely full. But in point of fact, that battery does not have minimum capacity in it, okay? That battery has some sulfation, and so it will not meet the minimum capacity test, but yet the healthy part of the plates are fully charged, and that's what the voltmeter is telling you. So that's what "don't be fooled" means. Don't assume that your battery is healthy because your voltmeter says that it's fully charged. State of charge does not equal state of health, and that's a very important point to realize. The only way to know if your battery has minimum capacity, which for a Concorde battery is 85% capacity, which means it's going to give you the C1 rate, whether that's 30 amps or 40 amps, whatever that battery is rated at for 1 hour, it's going to give you that for 51 minutes, okay? That's an airworthy battery. So don't let your voltmeter tell you. If you have a mechanic, you have a technician you take your aircraft to, and you ask him about your battery during annual, "Oh yeah, I charged it up, everything's fine." You need to find another technician, because that battery needs to be capacity tested every annual to ensure that it has minimum capacity. This is just a quick slide to help you understand that a 12-volt and a 24-volt battery that have 12 or 24 volts in them are not fully charged. Their state of charge is 25%. So 12.9, 25.8 or above, that's 100% state of charge with an aircraft battery. How do you know when you have a battery that's fully charged? It's not really an issue of depth of discharge or state of charge. It has to do with the charger and watching the amp rate. If you have an older charger, when you see that current rate slow way down, and I'm talking down to an amp, amp and a half, half of an amp, you've got about 2 more hours to go to charge that battery fully. But that's what you're looking for. If you don't have a really fancy charger that is set up and designed to read that, just watch that current rate. When it slows way down to around an amp or a little less, you got a couple more hours to go. I get a lot of questions about concave and bulging sides in sealed lead acid batteries. I just want to let you know, if you see a battery that's sucked in like you see here in the picture, or it's bulged out like a basketball, sometimes bulged so much you can't get it out of the battery box, your battery is operating normally. You can call me and talk to me about it. I'd love to talk to you. But that just means your battery's operating normally. All sealed batteries have +1 PSI inside them. And sometimes when they go to altitude, and if the conditions are right, the battery burps at altitude, you come down fairly quickly, you can suck the battery in. If the opposite happens, you can bulge it out. I want to let you know it can take up to a week for that battery to adjust to its normal look. So be patient with it. If it doesn't obviously happen after that period of time, you feel free to give me a call and we'll work on a solution for you. But just know that that's a normal look and it can take up to a week to adjust. Discharge rates. This is a big difference between flooded and sealed batteries. Flooded batteries lose roughly 20, and this is sitting idle with draw on the battery. So it could be sitting on the shelf fully charged, or it could be in the aircraft with everything turned off. A flooded battery will lose 25% of its energy every 30 days at a little better than room temperature. But you can see if the temp goes up like it is here today in South Carolina, 15 days is all it takes to bleed 25% of the energy out of a flooded battery. And obviously with extreme heat, it can happen very quickly. Sealed lead acid batteries discharge 3 times slower than that. And if you don't get to fly very much, it's a great comfort to know that you've got a sealed battery in your aircraft because it's holding its energy much more efficiently than a flooded battery. So another good reason to fly sealed lead acid batteries. What's the minimum level of voltage that you want to take a battery down before you actually damage it? I don't think anybody out there thinks you can take it all the way down to 0, but you certainly don't want to do that. But the answer here is C. For a 12-volt battery, you don't want to get it below 9 volts. For a 24-volt battery, 18 volts is your minimum. If you get below those numbers, you can get what's called reverse polarity. That's sort of like the diabetes of batteries. Once you go across that hump, it's very difficult to get back over to the other side. In fact, Skip used to say, if you catch this quickly enough, meaning within the hour of it happening, and you get that battery recharged, you stand a 50-50 chance at no damage. As that time creeps on, the percentage of not damaging that battery goes way, way down. If you get yourself in this situation, recharge the battery. The first thing you want to do is a capacity test, as we talked about earlier, because the only way to know what the state of health of the battery is to do a capacity test. So if you run into this situation, charge it back up and then run a cap check on it and see if the cells are okay. At what time should an inactive lead acid battery be boost charged to prevent it from sulfating? It's not really an issue of time. It's an issue of temperature. So if your batteries are living in hot environments, they're going to need to be boost charged a little more often. But it's a matter of voltage. Anytime your battery gets down, if you're running a 12-volt battery, to 12.5 volts, you want to put that battery on a boost charge for a couple hours. 25 volts for a 24-volt battery. You get down to that number, a little below, go ahead and throw it on a boost charge for a couple of hours. Is it okay to fast charge a lead acid battery? This is where we differ from my friends at Gill. They do not like fast charging. I've never been able to get a really good answer as to why that is, but we like it. In fact, our batteries can accept charging rates up to 8 times that C1 rate. So if you remember, I told you, you can have a 12-volt battery. Our RG35AXC is a 33 amp hour battery. You can pump up to 8 times that amp rate into that battery. So we're pushing 320. Well, no, what would that be? That'd be more like 250. My math's a little bad on a Saturday. But bottom line is, I don't think you're going to find a charger that will give you that much of an amp rate. The point here is to let you know to ramp up the current, 30, 35 amps on a charger, pump it in there. The point is at the bottom. You must control the voltage. If you get too much voltage into these batteries for too long, you can actually dry the mats out, and then you have a boat anchor because there's no way to fix it. That's what makes the battery minders so great. They're temperature compensated. So if it's hotter, it pushes less energy. If it's colder, it pushes more voltage. But you must control the voltage. But you want to get them charged back up as fast as you can so the batteries don't have an opportunity to sulfate. When should you check the aircraft charging voltage? Annually, in the summer, in the winter, when your bride tells you to do it? Well, the answer is annually. And this is the voltage regulator settings for both 12-volt and 24-volt systems based on temperature. Now, I'll give you a quick cliff note here. If you're running a 12-volt battery 13.8 to 14.2 is your optimum setting for your voltage regulator. 27.6 to 28.4 would be the optimum setting for a 24-volt battery. But I'll give you a little freebie here. If you're willing to adjust your regulator twice a year, in the summertime, you want to run that down to around 13.8. If it's dead cold of winter, you want to run it up to around 14.2. If you're willing to adjust a couple times a year, you're going to extend your battery life just a little bit longer. What is sulfation? Well, this is what it looks like under a microscope. It is not something that magically kind of gets inside the battery when it's deeply discharged or it's been partially discharged for a while. It's the lead oxide on the plate that is naked of a charge. And if it's been naked of a charge for a little while, the lead oxide turns into lead sulfate, and it builds up on the outside of the plate, and it acts as a barrier. So you cannot get a charge through that barrier to the soft, healthy material that's inside of the plate. If you think of a piece of bread, a slice of bread that's really moldy, if you pull that mold away, the inside of that slice is really nice and soft and healthy. Battery plates are just like that. That sulfation builds up on the outside, so we need to get rid of it. But why does it happen? These are all the reasons. Some of the things we've talked about: leaving batteries discharged for long periods of time, repetitive undercharging. Let's say you go out there and you update the card for your avionics. You do it 30, 35 minutes. You don't charge the battery up. It's a couple weeks before you go back and fly. Or you've flown a couple times around the patch for 20 minutes. All those things, if the battery is not recharged, then that part of the plate that's void of a charge will begin to sulfate. The longer you let that condition persist, the harder that sulfation gets and the more difficult it is to remove, okay? And eventually you get to the point where you got what's called hard sulfation, and then you've got yourself a boat anchor. You really can't fix it. So what can be done to correct it? Well, if you remember when we talked about the charging methods a few minutes ago, we talked about the constant current charge method, okay? And if you have a charger and you have a constant current mode on your charger, you can desulfate your battery. And it's a very simple process. First of all, you want to discharge your battery down to the endpoint voltage. For a 12-volt battery, that's 10 volts. For a 24-volt battery, that's 20 volts. Once you get it discharged down to that point, you're going to set the charge to a constant current. You're going to take that C1 rate that's right on the front of your battery. It's a sticker, and it says it, C1 rate, 33 amps, 42 amps, whatever it might be. You take that C1 rate, divide by 10. So a 33 amp hour battery, the RG35AXC, divided by 10, that's 3.3 amps. So we're going to set the charger to 3.3 amps, set the voltage as high as it'll go, which doesn't sound right if you've been paying attention. And then that's a 16-hour process. You let it go. About every 4 hours, go over and touch the side of the battery. If it's getting a little warm, that's okay. What you're looking for is too hot to touch. If the battery ever gets too hot to touch, shut it down, let it rest for 4 or 5 hours, and then do a capacity test. Because the only reason that you do a constant current charge is if your battery has failed capacity test, okay? And what this does is it cleans up the plates, returns the lead sulfate back into lead oxide so that it can accept a charge and get you back up above minimum capacity. But any good maintenance shop will have a charger that has a constant current mode, and they can take it. And you would be amazed. I say this everywhere I go. The effectiveness of constant current charging to return a battery to an airworthy status is amazing. Granted, it takes some time on the charger, and you can actually break it up into 2 8-hour segments if you desire to do that, but it's a 16-hour gig. And if you're willing to go through that, I can almost guarantee you, that every time it's going to bring that battery back, unless it's got hard sulfation, and then it just won't work. But there is a way to fix that. All right, let's talk about capacity testing. What is it? What are the parameters? How do you do it? Well, way back in 1977, aircraft batteries were all rated at a 5-hour rate. So if you looked at a battery, very popular battery on the experimental side, particularly with the RV guys, is the Odyssey battery. That's a 11 amp hour battery at a 5-hour rate. So at first blush, you think, okay, that's 11 amp hour battery. If I need everything that it'll give me for an hour or 50 minutes, it's going to give me about 11 amps. And that's not true. There's a formula that you have to use called Puchert's Law. and it's a very page-long formula that will help you figure out what's the 1 hour rate of an 11 amp hour battery rated at 5 hours. And what that simply means is it'll give you a little bit less. So if I need everything that battery would give me for an hour, it would give me about 3.5 to 4 amps is the bottom line. So in 1977, somebody stood up and said, look, this doesn't work anymore. It's too confusing. And from that point on, batteries for aircraft became 1 hour rated batteries. So it was very easy to look at an aircraft battery, look at the ID sticker on the front. If that's a 33 amp hour battery, if it's healthy, it's going to give me that for a minimum of 51 minutes. So cap testing is a very easy process. You start with a fully charged battery, and then you're going to discharge that battery. And by the way, you need a capacity tester to do this. So you're going to need to take it to your local maintenance shop to have it done. But they'll discharge it at the C1 rate. Again, we'll use the 35 AXC as an example. So they're going to discharge that at 33 amps. And when you get down to the endpoint voltage, which for a 12-volt battery would be 10 volts, they're going to stop the watch, or the tester is going to stop automatically. If you've made it to 51 minutes, that's an 85% capacity battery, and it's airworthy. If it makes it to 55 minutes, it's 90% capacity. If it goes the whole 60 minutes, obviously that's 100% capacity. And you will occasionally have batteries that are so strong that they'll go 102, 103, 104%. But what you're looking for is a minimum of 51 minutes for an airworthy battery. But it's very simple to do. So at the endpoint voltage, you just check the time, and then you're done. Capacity testing, minimum capacity, there's a little bit of confusion out there in the industry because the FAA and GIL say that the minimum capacity for a battery is 80%. Now the FAA does say in 43132B that 85% is the minimum capacity rate. We here at Concord, our minimum capacity is 85%. People ask us all the time why there's a difference, and it's no more complicated than an added margin of safety. Sometimes that extra 5 minutes is a really, really good thing. Okay, care and maintenance, cap test intervals. We'll stick with recips, but either recip or turbine, your first capacity test is 1 year from installation. And then depending on what happens as a result of that test as to when the next one is done. If it passes above 85% with a piston battery, your next one is next year. If it passes between 85 and 90%, your next one is at 6 months. For turbine batteries, it's a little tighter tolerances. If it passes above 85, we still want you to test that battery 6 months out. If it tests between 85 and 90, then we'd like you to see that battery tested again at 3 months, because the turbine environment is a pretty violent environment for batteries to live in. But typically for the piston folks, which is most of you out there, I would assume, I want you to get your batteries capacity tested every year. A lot of folks don't. They put the battery in. If it starts the airplane, they think they're good. But from an airworthy standpoint, and that's what we're emphasizing today, if you want an airworthy battery in your aircraft, you need to test that battery every year. Because just as we said before, just because the voltmeter says it's fully charged doesn't mean its state of health is minimum capacity, okay? All right, best way to clean them, very simple answer, a rag and some water. No solvents, no detergents, no Joy, none of that stuff. Just a rag and some water to wipe that thing down. This is another easy one. When should you replace them? It's very simple, when they don't meet capacity. Now, I know folks who change their battery every 2 years no matter what. I appreciate it. My kids eat better. I really do appreciate it. But it's not necessary, okay? The only time you need to replace your battery, technically, is when it doesn't meet capacity, when it doesn't meet minimum capacity. But you can change them as often as you like. Installation eligibility, there's several different ways to get a Concord battery on your aircraft. Obviously, if it's type certified with it, it's going to come with it. Y'all are familiar with STCs, PMA, parts manufacturing approval. We've recently TSO'd all of our batteries, which means it's an airworthy item out of the box. It's not application specific. This is very good for production aircraft. If somebody like Gulfstream or the military or Piper or Cessna, whoever it might be, wants a certain size battery and a certain power band. We can just give them battery. They can go fly it. They don't have to do a lot of independent testing. This is something I want to highlight. This is an FAA advisory circular, AC 2327. Now, typically, if we were all together, I would ask for a raise of hands of how many folks know about AC 2327. And regardless of whether it's owner-operators or IAs, one hand in a crowd of 20 or 200 will go up. This came out in May of '09. It's titled Hard to Find Parts for Vintage Aircraft. And it's probably, in my opinion, one of the best ACs that the feds have ever written. It's an 18-page double-sided document. And the applicability paragraph is what we've got here up on the screen. It applies to small aircraft TC'd before 1980 that have a max weight of 12.5, fixed-wing unpressurized recips or sailplanes. Follow-on TC models of the same aircraft or derivatives meet the criteria. In layman's terms, if you have a 2019 Bonanza, it falls under this because the original TC was prior to 1980. If you've got an older Piper, an older Cessna, whatever it is, it's going to meet the criteria because the TC was prior to 1980. On page 12, it deals with batteries. And it says, and I'll quote here loosely, if you want to replace your G25 with an RG25, and it's plus or minus a pound, and it's the same voltage, it's a logbook entry. Now, I would encourage all of you to weigh your batteries if you don't believe it, because a flooded battery that's activated will be within that range of a sealed activated battery. The only battery in our stable that won't match this is the RG35AXC. It is a couple of pounds outside that envelope, but otherwise, all of the other batteries typically are within that weight. So you can just swap out from a Gill to a Concorde, do a logbook entry to that effect, and away you go. You really don't need to do the paperwork. Now, there are several different ways if you want to do the paperwork. MODs, STCs, 337, service bulletins, there's a couple of different ways that you can do it. If you want to find out if your aircraft is eligible, and I can pretty much tell you that everybody on this call, you are eligible for Concorde batteries, but you can go to concordebattery.com and check out our eligibility list. Here's the warranty. For piston engines, it's 2 years or 1,200 hours. Turbine engines, it's a year or 600 hours, because like I said, they live in a pretty violent environment. Now, I will say this, just as an aside, if you have a battery that has a workmanship defect in it, there's something wrong with the battery internally, they will fail in the first 100 days, almost without exception, okay? So here, if we'll tell you, if you have a battery that's going to fail or that does fail for some reason, and this is certainly rare with us, if it fails inside of 180 days, we're going to send you another battery. We're probably going to ask you to send that battery back to us, though, because we'd like to open it up and take a look at it. It's not because we want to figure out, oh, you did this or you did that, Mr. Customer, so we're not going to give you a battery. We're going to send you a battery. We just want to figure out what's wrong with that battery. If it's something we did, if it's something you did, we all learn together and we move forward. But we may ask for the battery back if it fails that early. And then we actually prorate the warranty out to the useful service life remaining. So in summary, open circuit voltage does not equal state of health, which is capacity, the thing that we've been talking about off and on all day today. You want to make sure that you cap check your battery each year, especially if you fly IFR. Now, I'm a pragmatist. If you go out and fly on Saturdays and you fly around the patch and it's sunny and you're 1,500 feet and you're out there for an hour, that's not as big of an issue. I get that. But if you're an IFR pilot, you're occasionally an IFR, or you're in situations where you can get into IFR unintentionally, you need to make sure that your battery has minimum capacity in it. Capacity tests are the only way to determine airworthiness. Putting a voltmeter on it does not determine airworthiness. Don't jumpstart the battery. You remember we talked about that earlier. Take the time to get that battery charged back up before you go, because we want you to get to where you're going. Keep it charged without overcharging. The battery minders are a great way to do that. Having your voltage regulator set properly is a great way to do that. That's all I've got for you guys today. I can't thank you enough for taking this time on a Saturday to listen to us. I hope it was helpful to you. But thank you so much for joining us. Okay, it looks like I've got some questions here that I'm going to go through very quickly. Will a battery last longer if it's hooked up to a battery minder when the plane is parked? The answer is yes. Now, for Art Friedman asked this, if you have a new battery, that's when you need to get your new battery minder. That's when you're going to get that optimum life. But I will say that at any point particular in the battery's life, if you'll use a battery minder when you get out of the airplane, obviously you need to have access to power to do this. But if you'll hook up that battery minder when it's parked, the battery minder can be left on there for a week, for a month, for 6 months, even a year. So it will last longer. Linda asked, how much longer will it last if using a battery minder? We tell you your battery is going to last 3 to 5 years if you go fly once a week and you go at least an hour when you go. If you were hanging out with me at Oshkosh at the booth this week, about every 8 or 9 minutes, somebody will come by the booth and say, hey, I've got 7, I've got 8, I've got 9, even double digits, 10, 11 years on a battery. The commonality with all those folks is that they're using battery minders. So you will get some extended life using a battery minder. Gary asked, yes, while I fly, I have a voltage meter of 12-volt system. After startup, it shows 12.9 to 13.3. While flying, it drops to 12.4 to 12.8 and then remains constant. I know that if it drops below 12, then I have a problem, but it sounds like these other readings help understand the performance of the charging system. Well, it needs to be charging 13.8 to 14.2. So if that's not happening, then the first thing you need to do is get your voltage regulator checked. That's the first place to go. Typically, when you have an issue like this, is have your voltage regulator checked. Let's see what else we've got here. And Kent, I may be stepping over you here, but I'm just kind of paging through these.
Go for it.
Model of the battery minder. That's a great question, Ted. If you'll just go to batteryminder.com, I don't know the number offhand, but it ends in S5, and it's a Concord specific battery minder. Gil, several years after we worked with them, asked them to make them one as well. We don't really like the Gil battery minders on our airplane, on our batteries, because the float voltage is a little high and it can dry out the mat. So make sure you get a Concord specific battery minder, either 12 volt or 24, because it won't do both, and just make sure it's the Concord model. What is the best capacity checker available, bang for the buck? Gordon, you know, cap checkers are not cheap. Bench models start at $1,000 and go up from there. The best thing that you can do is get to your local tech. If he's worth his salt, he's got a capacity tester on his bench. Robert White, I don't know of any inexpensive capacity testers. And I think that's about all we had, Kent.
Yeah, I've got 2 questions just for on my side of the spectrum here. Cleaning recommendations of the terminals. You said just water and a lint-free rag. Nothing like the old-fashioned, you know, like an abrasive thing to remove any oxidation. It doesn't.
Yes.
Okay.
Yes, you can use, you know, wire brush, scuzz brush, anything like that to remove the corrosion for sure. Okay. You can do that, but in terms of, you know, wetting the battery, water is really the only thing we want you to use. You can just take a wet rag and scrape the remainder of that corrosion once you've scuzzed it off of the terminals with a brush or a wire brush, soft wire brush. You can use that. Okay. But water is the only liquid.
All right. Now this is going kind of back, like you had started by your father told you this, never to put a battery on the concrete ground and all that kind of stuff. There used to be an old school of thought that when you reassemble the terminals after cleaning, maybe use a little like a lithium grease to reduce the possibility of oxidation or corrosion. Is that still
You know, to be honest with you, the only thing I've ever learned from that is it makes my terminal bolts go on and off a lot easier. Okay. That's for sure. I would think that it would probably suppress it a little bit, but it's not going to be noticeable. And the problem is, For instance, some of our competitors have steel terminals. And when you get that copper ring terminal on it, it is going to begin the corrosion process eventually. The lithium grease might slow it down a little bit, but it's not going to prevent it from happening.
Okay. And a final question is, let's say I get a battery, it's brand new, it's out of the box, and I'm removing it from the box, and it accidentally slips out of my hands because it's 100 degrees, my hands are sweaty, and it only falls, let's just say 5 inches, in a small corner of the battery has got a little dent in it. I don't see any cracks. Do you think I should that be,
well,
bring it up?
That's an excellent question. 2 schools of thought. You know, when we were kids, we would take a piece of colored plastic and bend it, and we get that white crease in it. If you see that white crease anywhere in the battery, in the case, after it's been dropped or dinged, then that's an unairworthy battery. Obviously, if the case is cracked, that's an unairworthy battery. If you just see a dent here and there, something's happened, or you just bump it from a few inches above the floor, I would really recommend that you capacity test that battery, make sure it's fully charged, and then have somebody do a cap check, because that's the only way to determine if you've internally damaged it. If you all were on Vince's presentation yesterday, he would tell you that if you drop a spark plug once, you've got to drop it the second time, and the second time you're dropping it in the garbage because you don't know if you've cracked the insulator or done internal damage. Sort of the same way with a battery. So any kind of instance like that makes it a little cringeworthy, and you know your gut tells you if it is, cap check that battery. It's the only way to know. It's the only way to know.
And it looks like Gary has come back on with another question. He's got a solar charger with a voltage regulator for his 12-volt system. He was recently told that the regulator is not an aviation regulator and could be a problem. Is that true?
So he's got a solar panel that he uses to charge the battery that he clips into the window or something like that. Is that right?
That's what it sounds like, yeah.
Okay. So if he's got a voltage regulator on his aircraft, did I understand that right? It's not aviation specific?
Apparently it is.
Maybe.
Yes, true.
Okay. I wonder if that's an experimental aircraft, because obviously you don't want to be flying something that's not approved for the aircraft. But the only issue we have with solar panels, and VDC Electronics, who makes the battery minder, has actually just recently put out solar panels. The only issue is the amp rate is a little lower. Now, it still works, but it's not quite as efficient. You know, people have asked us for years, hey, my airplane's on the ramp. I can't afford a hangar, so I don't have power. How am I supposed to keep my battery charged? Well, other than taking it out and taking it with you, solar panels would seem to be the perfect solution. And so we've kind of prodded VDC for years to come out with a panel. And as I understand it, they do have one now. The only downside is they're just not quite as efficient as you'd like them to be. They're close, and they do work. Mm-hmm. They're just not quite as efficient as a plugged into 110.
Okay. And it does look like Gary came back when you asked if this was a not certified airplane, experimental. He did say yes. Okay.
Yeah. You might need. I would recommend that he call the manufacturer of that voltage regulator and ask them that question directly, because they would know one of their techs would know right off the top of their head if that was okay or not.
Okay, great. Excellent. Thanks, Chris. Appreciate that. Excellent. All right. I think that wraps up the Q&A part of that, which is wonderful.
Thank you again to Chris. Thanks to Aircraft Spruce for sponsoring. Thanks to all of you for being here. Good questions.
Yes. Wonderful presentation. We appreciate your time, Chris, very much on a Saturday afternoon.
No worries. Glad to do it.